and what types of data you can have, data representations you can have, what is wide data, what is long data formats, and how you switch between them and use the best features of these type of data. Then in the second half of in the second part of the time, we will go through more visualization and plotting techniques to have more control over what you're plotting and how your figures would look like. So you're very familiar with Servi's dataset by now, and you already have it. For the people who have opened another notebook and they want to start from scratch, this is how we get the service data. You have already, again, if you're continuing from morning, you already have imported pandas, so you don't need to do this line either. So we will start from, maybe again, take a look at the service data to make sure that, just to look at the head. So we'll have record IDs, month, days, and different features from the animals that were caught in the traps. So let me put up this part of the lesson for now. So there are, this way of presenting your data in a table format is very familiar to you. It's the way that we usually put the statistics, we display statistics or our data that is very much readable for human eyes and understandable for human eyes. In each table, you have the columns will be the values that you have measured, and each row would be one of the observations. So person A, you measured their weight, height, and age, and you put it in a table. Person B, the same thing. This is very good visualization of your data, putting it in a table. You will probably do this for papers. You definitely should display your data in final statistics in such tables for your papers. But for all the different programming languages, it's the long format data or the tidy data that is more reasonable and more applicable, because the long format is like this. So it has a repetition for your eyes, for humans, but for programming languages, it's more efficient because each of your values has its own value right beside it. And every row now is a key value pair. So person A, weight was 70. Person A, height was 170. Person A, age was 32. This way, then your programming languages can read your data by indexing, for example, over the person or over measure. That's probably how you also do, for example, when you want to do ANOVA or any kind of statistical analysis, you more easily, or the program more easily indexes your parts of your data and works with it. So we should be able to work with these two types of data sets and be able to switch between them. So we'll go through how we can do this, and pandas have different really easy functions to work with this. So let's go back to our thing and start. First, because this was, if you remember all morning, this is a really huge data set. Let's first get some subset of the data so that when we are switching between the different tables, you will be able to see it. So let's start, I'll put it up. Let's start getting a subset of your data. So getting a subset of the service data set. It's always good to comment your code so that later when you return to it, understand what you are doing in each cell. I really suggest this commenting or headlining. So for example, what I want from species, I only want albigula. I can't read them. Albigula and flavus and Mariami. From plot ID, my plot ID sub or subset, I want only the ones between 5 to 10. So I'm listing a range between 5 to 11 so that I include 10. Then from columns, I only want to get columns record ID, species, weight, and plot type. Now I want to get only this subset of my data. So I define these to now subset my data, saying you already know these from morning. So I define service sub, my subset. I just named it this. I want all the logs that have service that have this, their plot ID. Is in the plot ID sub that I defined. And I want the survey column species that is in my species sub and all the columns that I defined as calls. This is getting it.
Why did you use a dollar sign instead of an and?
Sorry, no, sorry, that should have been and. Sorry, why did I put and? Dollar. Let me see if I typed it right. Service plot ID is in plot ID sub, and service species is in the species sub, and the calls, or the columns that I defined. If I now look at the head, or yeah, let's look at the first 10 rows. So we will have, remember that we haven't used the reset index, so we are getting the previous indexes. We have record ID, species, weight, and plot type that I defined in my columns, in my calls variable. And I'm getting all the logs, all the rows that have the plot ID from 5 to 10, and all the rows that have the species of Albigula, Falvus, and Mariami. So if you look through all your data, you will only see these 3 species and these plot IDs.
Can you scroll to the second half of the
To down? Yeah. After and. Good. So everyone got this part. Everyone got the same 11 lines. Oh yeah, it should be 11. Ten lines. Sorry. Yes. Oh, sorry. So I defined the subset, the things that I wanted from the data. Put up your yellow, green stickies if you're fine. And I'm subsetting, only getting the rows and columns that I want, just to make it easier for the rest of our. I just wanted to plot. If you look at the plot IDs, they're from, I think they're from 1 to 20 something. We wanted only the ones from 5. This is just random. Yep. I wanted from 5 to 10. So this is the numbers from 5 to 10. Let me show you how it is, what it is. Oops, sorry. What did I do? What did I do with it? This is these numbers. So it's a list of numbers, 5 to 10. And I'm telling it, and I'm putting these numbers into this variable. And then when I'm subsetting the data, I'm saying, hey, take only the plot IDs that are either 5, 6, 7 to 10. The survey from plot ID column, take anything that is the same as numbers in plot ID sub. So in each row, when it sees that either it's 5 or 6 or 7 or 10, it takes it. It takes the row. Otherwise, it leaves it. Everyone is fine? So let's say we want to look at the mean body weights of our animals in each species within the plot type. If you look at the first, let's calculate or estimate these or compute the means. Again, this is something that you're probably familiar with from morning. I do service sub, let's say ESP. I want to compute the mean now. Let's do this to make it more visible. So I want from service sub. Yeah, I do group by species and plot type. And weight. I want the mean. And I want to reset the index. If you remember, we didn't reset the index. We want it to have its own index. We don't want to keep the previous indexes. And it ends. And let's look at. Am I missing this? Sorry, this shouldn't be here. Okay, now it's good. ESP. Sorry. What am I doing wrong? Oh, it's just the indentation. So we calculated here, we grouped by species and plot type, and we got the mean, and we reset the index. So now we have for each species, in each plot type, we have a weight. We have a mean weight. Come for a second. Why don't I have the flavors there? Maybe wrong. I should do it again. I don't know why. Because, sorry, I have a lot of typos. Here, I chose a name that was not in the data set. Instead of flavus, I typed falvus. So that's why I didn't have this later in my data. Sorry, I just corrected this typo. And now when I run this cell again,
It's at LA.
it's still wrong?
Yeah, it's LA.
Oh my God. Sorry, my eyes. I don't know these species. Hi, and I haven't worked with this data set. Okay, perfect. Here they are. So do you all have these? For each species, for each plot type, you have your mean weight. Yes? Perfect. Now we come to wide and long data formats. So if you look at this, you can see that this is a long format data. Why? Because we have repetition of each. We have key value pairs. Albigula, control, its weight. Albigula, rodent exposure, its weight. Albigula, short-term, again, and another plot type, its weight. Albigula, the fourth plot type, its weight. For flavus, the same. So this is the long format data. This is very good for your programming languages when you want to apply any statistics, you want to have this data. But for yourself, if you want to look at it and see, okay, have an idea of how the weight is distributed among the species in plot types, you want to see it in the table format that we are all familiar with. What we do here is something using a function in pandas called pivot. So I do service sub DSP, my data set, my variable, or my data frame, dot pivot. Arguments to pivot include the rows that are the indexes and the columns, the thing that you want to be in the column, and the values. So your index you want to be the plot type, for example. Your columns to be species and values to be weight. Pivot.
Surveys, so SU.
And it's very good to always use the tab key to don't type it if you're bad at typing. Here is the wide format data that we are familiar with. We have each of the plot types in rows, all the 3 species in the columns, and you can easily see that, okay, my alveolar species has the highest in this plot type. The other ones have these mean weights, and you can look at the data.
Can you make that readable again?
Oh, sorry. Here.
Yeah.
Good. So this presenting the summary statistics in wide format is so common, and you use it and you need it so much that the pandas have another function that uses the aggregation function and the pivoting both in one function. So we didn't need to calculate our means first, our mean weights first, and then do the pivot. We can do it both in one function, and that's pivot table. So we can do pivot table on our service sub, not service sub GSP. So service sub dot pivot table. Then my index, I want to be again the plot type. My columns to be species. And my values to be weight. Here you get exact same table that you had above, without the need to calculate that service sub GSP or that mean weight per species per plot that we did. So if you have your data in wide format, you can do, for example, functions like correlation, pairwise correlation. So let's do a pairwise correlation between our columns. The same thing. So this, when I do this line, it only shows the data for me. I haven't put it in another variable yet. So just copy this line and assign it to a variable so that you can use it. So I use service sub pbt and just paste the same line. Pivot table. So that you're assigning this pivot table to this variable service sub pbt, and now I want service sub pbt. Haven't run it yet. That's why I can't. pbt.core. Now your table, the values will be the Pearson correlation coefficient between the columns. So it really makes your life easier.
And the p-value? No p-value?
No p-value. I guess you can play with this to also show you the p-value. You can look if we had our inspector here, you could open it and find how can we show more data. One more thing is that you could change your. Let me copy this again. Copy and paste this pivot table again. One thing that I want to show you here is you could change the columns and rows with each other. Just change species, bring a species to index and plot type to columns. And we will have it this way if you wanted to have another way of visualizing and then calculating things on it. And also, one other thing that you could do is, let's again copy the same thing again. Sorry. This pivot table. You could use another aggregate function instead of mean. You could add agfunc equals median and have the median instead of mean. So this was basically how to go from long format to wide format and what things you can do with your wide format data and how you can and what things you can see in it. Now let's say we want to have more. Is everyone fine? Is everyone there? I'm pretty slow, so I hope. Sorry?
I need a few more seconds.
Sure, definitely. So you can look up what other functions you can add in aggregate function. You can add max, mean, all different functions. Just Google for it and you find all these other aggregations you can apply immediately on your wide format data. So when we want to get data to the most suitable format for analysis, we want to transform it or reshape it from wide to long format, and that is done by a function called melt. So if you remember, we had this service PBT. That we had the mean weights when we use median and etc. We didn't assign it to any variable, but we have this variable service sub PBT that is our wide format data with our mean weights. You can see that it was pointed to you a few times in the morning that here. These are actually the indexes. We don't have an index for them. So let's first have an index, make an index for them. by using reset index. So I want my service PVT to have indexes. Again, service PVT. I'm replacing my data with a version of itself with a reset index. Now if I print it, it has these 0, 1, 2, 3 indexes. Now, we want to use.
What's the shortcut to add more rows?
Huh?
What's the shortcut key to add more rows?
Shift insert. If yeah, if it's Windows, does it work? Isn't it shift insert to add more cells? For shift enter, sorry, shift enter.
If you want to add a shift enter, press new cell if there's no cell already there. If there is a cell already there, you press alt enter. That will put a cell into it.
Now we want to use melt. So this is our wide format. We want to use melt to make it a long format. The minimum variable that or input that melt needs is the name of the column that we want to keep intact, and the rest will be repeated. So for here, we want, for example, to keep plot type. So I say service PVT dot melt, and the ID vars, the ID variables will be plot type. That's it. Voila. We have our plot type that is being kept, the control, rodent exposure, and then it repeats for each value of a species, the mean weight of a species. So control, albigula, rodent exposure, albigula, short-term crowd exposure, albigula, spec-tab exposure, albigula. Again, the plot type repeats for the other species. Oh, I shouldn't. So it was just having ID variables as plot type, the column that we want to keep intact. You can be explicit and define everything else as well, so that you, for example, have more control in keeping some columns and get rid of other columns. So let's define everything. The other inputs that melt can get is, let's do service PVT dot melt. Our ID vars is plot type. Value vars, value variables or value vars. I want to just keep the two species of albicula and doesn't get it. Flavus. And also get the variable name, put the variable name as a species, and value name as weight. This is just for naming your columns. If you run it, you see that you have the same long format data, plot types kept there, and species and weights repeating, but you don't have the Mariani species here. All good? So now let's do it yourself. Let's have a challenge or 2 challenges. Make a wide data frame with year as columns, plot ID as rows, and the values be the genera per plot. And you can use the NUnique that you learned in the morning, and remember about resetting the index. I'll keep the last part of the code if anyone is, or maybe I go to the part that we were using, the pivoting.
I need a question there.
Oh, okay, yeah, you're right. Sorry. Sorry. Okay, here is the question. So I keep the question. And put down your sticky note, and when you're done making the table, put it up. And feel free to discuss with each other. I know that it's afternoon.
you need help, put up a red sticky. Already.
Should I go?
You might want to go through it before,
Okay.
and just ask them to provide.
Before the should I put it there?
No, before people are ready. Even if they're not done, you can just ask them to try to something as we start and stuff. And then you can also just if no one wants to give their example.
Okay.
Is there a function to do the second one, or
It's the melt that we talked about. So does anyone volunteer to give the answer for the first challenge? Tell me what to write. Where is my? We can, or maybe put up your yellow stickies if you're done, or you want to continue. Okay. I guess I go. So I want to, I name it genus Y, genus year. So I do genus year. I first do this group by thing before making it wide. So I want to, maybe I can go higher. So I do service group by we wanted year and plot ID. And then we want column genus. And then we want the unique numbers of genuses, genera, unique. And unique. And we said that we better reset index. We better do reset index. If now I want to make this wide format. So I use a pivot table on this data frame. PBT as genus. call it white. My index, I want my index to be .id. And my columns to be year. Now, if I plot the head, we can see that I have all the years as columns, the plot IDs as my plot ID. I'm just showing the 5 first rows, of course, because of the head. But each value is the number of unique species, or the number of species that were caught in each plot ID for each year. So 2 species were taken for 22 animals were caught here, but 2 species from 2 species. Here are 3, 4, 7 in each year. So, and you can see that this is a wide format. It says genus is in the values, these are the years, and the rows are plot IDs. We could do this thing that I did in two lines. We could do the same thing in 1 line. Let's do it in 1 line, or in one function, serial function. So I do genus year wide, service group by, year, and plot ID. And the column genus. I'll go down here, make it more visible. Unique. These are all the same. Now I do this pivot table right at the end, because this is also another function. Everything that we had here, the same thing. I'll just copy paste. I have the same exact thing, but just in 1 line. Group by and unique, reset index, and then pivot table. Instead of first assigning it to a variable and then applying pivot table on it.
You know how to do previous code?
Yeah.
Just a second.
The only difference is that I first assigned this to another variable and then applied this pivot table on it when it could be another function in the same row, in the same application. The second challenge is pretty straightforward, as exactly as we did before. We want just to return the same thing to long format. So I want to write, what was my genus year wide? I apply melt. And I want my ID variables to be plot ID. I want to just show to you the head of it, just to not. Sorry, what did I do wrong? Yes, we want to. I don't know what I'm doing wrong here. Huh? Ah, sorry. I did. I am here. We should add a reset index again. Because we want to have these the plot ID before plot IDs were indexes, but I wanted to have index again. I wanted to have its own index. So I added another reset index here so that my plot IDs are one of my columns. So before I didn't have this resetting. So look at here. If I don't have this, I have plot ID as my sort of index column. But I should have an index to be able to apply a correct index, an index from 0 to something, to be able to use melt. So I have to reset index so that, look at the how it changes. I have a column for indexes. Now my plot ID is one of my columns, and now in melt, I can assign ID variables in plot IDs, because before plot ID was just an index column. But now plot ID is a column, and I have told melt to take it as my ID variable, meaning to keep it intact and repeat everything else. So here the part about reshaping data and transforming between wide and long finishes. Let's go. Okay. Let me for plotting, you got familiar with Seaborn today. Because I'm in a new notebook, I import Seaborn again, but you don't need to. You have Seaborn. As SMS. I want here to download another data set, the iris data set that you again worked with it a bit in the morning and yesterday. So I call iris, I assign iris to the load data set, iris. And I want just to take a look at it to explain what it is, just for people who don't remember. So iris data is a collection of 4 variables from 50-something flowers that scientists assigned 3 species to them. So this is, the species are assigned by scientists saying that, okay, we know that certain sepal length and sepal width are setosa, we have versicolor, we have virginica. All these 3 species are in these 50, our 50 samples are labeled based on their species, and we have 4 variables on them. Here I just put the mean of them, put the mean in each column, just group by species and computed the mean to be able to see it. Now you can use, you have used the bar plot in the morning. Let's do it again. Again, just because I haven't plot yet, I need to do matplotlib in line. I need to set context. You need to do the same every time. Set context as I do notebook. And I do on to scale as 1.3. And I do bar plot. Bar plot. I want my X to be species and my Y to be sepal length. Let's say sepal length. And the data is iris. I have the bar plot. What bar plot shows me is the mean and the error bar. So I have the mean, the same thing that we had here. For sepal length, we had 5, 5.9, and 6.7, 6.5. We are plotting it here. This bar plot is very common way of showing things, visualizing your data. Let's do a box plot. Oh, what? Am I too fast? Sorry. I thought you did it in the morning. So. Let's do box plot as well. We will go through this again because we want to find the best way of showing something, visualizing your data. The same thing. Here, I want to give it a spin. One thing that you can do is to assign your plots to a variable to then add things to your plot. For example, you want to add labels. So you assign it to X, for example. Same thing. Species. Y is your sepal length. Data is iris. And I want my width to be 0.3. I don't like the default. Now I can say my Y label, set my Y label as sepal length. With font size 14. And set my, not my, axis X label be nothing. I'll show you why. Because I already know the 3 species. I don't want the name species to be repeated here. So here it's plotting the box plot and giving it Y label here. If I don't do this, if I comment this X labels setting, I will have the species here. So it was redundant. I didn't want to show it an X label. You just need to set it as empty, an empty string. Those two quote marks means empty string. Let's do a violin plot as well. So the same thing, axis SNS violin plot now. I'll just copy and paste X, Y data. And axis set label and X label, set Y label and X label. Just copy it from the cell below, above, sorry. Okay, so this is the violin plot, approximate of the distribution, and a box plot in the middle. That's the default for violin plot. I think you also saw this in the morning. Let's do a swarm plot. Did you do swarm plot in the morning as well?
No.
Okay. Swarm plot shows all the data points for you. Let's do a swarm plot. Axis SNS dot swarm plot. Oops. Same thing. I will copy and paste the rest. The only thing that changes is the function name. And you will have all your data points jittered a bit so that they are sort of like a histogram. So here, for example, for Setosa, you had all these data points with the same value for around 5. So it just jitters them and places them all beside each other. So among all of these, which one do you think was the most informative one, and why? And which is the most true to the underlying data, and how would you know this? So which one did you like best? maybe discuss between yourself or just talk or just tell us what you think. So we had bar plot of the same thing, box plot of the same thing, violin plot that show the box plot in between and some kind of a distribution, and the data points, basically. Which one did you like? Or which one did you think it's? Anyone? So box plot showed a few statistics of the data. It showed the medians, the quartiles, it had the whiskers, then outliers. The violin plot showed an approximate of the distribution. So it was nice to have a histogram sort of the data. But if for big data, it can be a bit misleading. Swarm plots showed your data points, your raw data points. It was a good way, but again, for large data sets, it can be really oversaturated. So maybe we can use combinations of them. We will see it. We will see soon. But first, let me show you a very nice representation of why the worst of all of these was the bar plot. So you can see that, let me, you can see that in the bar plot, the only thing important is your mean. So this y-axis is the only thing important. And then the error. You have two parameters of the whole data that you're showing. You're not sure if, for example, this A from A, B, C, D data sets, if this A had any data points around 0. All this, the whole bar itself is irrelevant. You could only show one data point here with a marker here, for example, and it was enough, because you don't, this bar being full actually misleads you, because it doesn't tell, it thinks, you would think that all these values are sort of there in the data where they are not. If I go, let me show you an example. So an example of this bar plot, the real data that makes this bar plot can be this. So you can see that these two, for example, the A and B data set that have the same exact mean and error rates, they could be totally different data sets. So that's why people these days stress a lot on not using bar plots, because it's really not telling you much about your data. Or even here, for example, for this, a nice example is like it's bimodal distribution. When you're showing it with only one mean, it's like getting a group of birds with black color and a group of birds with white color, and tell that the mean color is gray. So it's not very useful to show to show your data with just the mean and the error rate, and also showing them side by side when their distribution or when the data points can be really different from each other. So it's always good, especially at some point at the end of your statistics, you will show probably with bar plots, but especially for yourself, visualizing your data sets, never use bar plot, never trust just two parameters of your distribution. So let's, for example, see how can we combine plots to see them better. Let's write this down. Let's combine a swarm plot and the violin plot that shows the distribution and your thing all together. So again, SNS, ax.sns. Sorry, I can't find my here. Ax is sns.violin plot. Oh, I should probably increase the too much. Okay, so that I can copy paste. Copy paste the X and Y and data. X is the species, Y is sepal length. Now I want, because I'm putting two things on top of each other, I want to combine plots. I put the color as light gray for this violin plot. And I don't want remember the default was that the inner part was a box plot. I don't want to be anything, so I put none here. Then on top of it, I plot swarm plot. The same thing, data iris. And the same axis, I want the same axis names and X label and Y label. And there's something that I didn't, I'm not sure if we did in the morning, just this finding. I'll show you what it does. Again, something is wrong, light gray.
Violin plot here.
Thank you very much. Clumsy. Violin plot. Perfect. So this finding, it just gets rid of these two lines on the two sides of your figure. It's just nicer. It's just for nicer visualization. So now you have your data points and your distribution on top of each other. And this is a pretty good way of showing your data and getting a sense of what your data is. So we all worked with sepal length so far. We had 4 to 3 other variables. Do you want to do one of these plots or a combination with another variable? Just use another variable to see how it looks. Visualize that other variable. Yes, please.
How does it know that you're wanting to combine the two things, or compared to just like plotting two things separately?
Because
like, why doesn't it just go like make one plot and then make?
That's a very good question, because I'm putting everything in X. So it's just plotting everything on top of each other because it's one, I'm assigning this plot to this X variable. I'm assigning this same thing to the X variable. So whatever I'm doing it in one plot.
But that second line doesn't like overwrite what I've already done.
Sort of, yes, it's on top of this. But because it is, if I had violin over this swarm plot, it would block it. But because it's swarm plot over this, you can still see the thing underlying it. Yes, it's plotting over each other. You should be wise. Yeah, you should be wise in using the orders of the order so that you're not blocking the things.
It's not over.
It's the same as well? Huh.
So that's a special thing, particularly with the
only the
scatter box will always be on top. How much specifically set the order of them. Otherwise, it is the order which you put in. We can show you later. It's a little bit like unintuitive, to be honest.
Maybe with box plot it will over maybe box plot and violin. Yeah.
But we can do a specific thing that.
Let me do this. How about if box plot was there too? See, the box plot is covered. It's good point. Maybe you want to combine a strip plot and box plot together. Let's do that. So combine the strip plot and box plot with sepal length. Where is it? A challenge here. Let's use sepal petal length. We were using sepal, sorry. Yet let's use any other variable and combine this strip plot and box plot. Okay, so just a note about the ordering. If you don't want to go by keeping the order in the lines that you write, you can define this parameter z order. Defining this z order defines the order of your plot if you're combining a few plots. So here I put the z order of violin plot as 1 and the swarm plot as 0. So although I put the swarm plot after, I'm plotting it after, but because I put the z order as 0, it's actually now hidden under the violin plot because that's 0 and then violin plot is plotted on top. Well, it's not intuitive if we don't want to do this. So I put the violin plot as 0 and the swarm plot as 1 because we wanted to see the swarm plot anyways. So that's another way. But if you don't define this, it will go by order. And you should know that for swarm plots or for these scatter type plots, they're always on top. So you don't need to worry. Okay, so let's do our challenge. Where is it? Here. Let's do the challenge. Is anyone, does anyone volunteer? Can anyone volunteer? Tell me what to write or come here and write it yourself. Or I can write it, tell me. So we do, go ahead.
It's like the same as we just did, except you can change the sepal length, the petal length, and then let's say the first one.
Yeah, let's copy and paste then.
Yeah.
Let's copy and paste here. And have, what do you like to have here as the variable? Petal length. And our function and our plots were box plot and strip plot. So here I put box plot. And here I put strip plot.
And you have to change the inner equals sign.
Where?
Box plot.
Yes, perfect. And then Y label should also change to petal length. What else should change? I think it's fine. Let's see. this is not very nice, actually. See this strip plot? Let's do something to make it, yeah, to jitter. So put the jitter as true. Now it's better. So that's another way of showing your data. Now, one other thing that I want to talk about is to, it's very good to work directly with Matplotlib library in Python and style all the different elements of your plot, even the high-level elements of your seaborn plots. You can change them and style them if you know the Matplotlib functions. So here we will go and work with Matplotlib functions a bit to find out how we can style and change our plots. So we need to import Matplotlib. I import it as PLT so that I don't need to type it every time. This is a very, very simplistic data set. I want to make my own data set. 1, 2, 3, 4. Is my X. My Y is 1, 2, 3, 4. Just for, or 1, 2, let's say 4, 3. We don't want it linear line, linear, just straight line. And then I say plot, PLT, Matplotlib, plot X and Y. Perfect.
Dot PY plot.
Huh?
No, import PY plot as well. Matplot.
Ah, yes, thank you. Yes, sorry. PyPlot. Matplotlib is in PyPlot. So we should import matplotlib.pyplot as PLT. I just did X 1, 2, 3, 4 and Y 1, 2, 4, 3 to have a really simple line to plot to then show you other things. Let's first, it's a good way to first make an empty plot. Because then you will have more control, you know. This way, you don't have any control over where to start, where to be the limit of your X, where to be the limit of your Y, and these kind of things. So we want, again, to assign our plot in our figure to an X. And this can be done by plot.subplot. When you put just nothing in it, PLT. Sorry, subplots. I created empty figure. Then I can add whatever I want to it. Then I add to X. I add my plot X and Y. Or I add as a scatter. A plot and scatter here. Or combine two plots. Make my scatter as red dots. So I color them as red. And plot again my X and Y as line style, as line as before. And I want my line style to be dashed. When you know these, changing the color, line style, and these things, they will be always useful for any other type of plotting. So now I have scatter plots.
Can you explain the fig notation? Like, what is that doing?
This X.
So that first line starts with fig.
Oh, fig.
So like, what does all that mean?
It's, sorry?
So, no,
Go ahead, you tell.
No, it creates a figure so that you can put the
Yeah, this.
graphs in.
Yeah.
Like, it's not a function.
No,
It's
just saying my figure, I want this X to be in it. Designing a figure. Assigning a figure.
Is this only in the pie plot?
Matplotlib. And Ernie, go ahead.
Sorry, just to add on. The function is the subplot. One of those things is figure, which is that entire thing. The entire thing is the axis, which is maybe not understood today, but if you think of it as like the y-axis and x-axis together by the axis. But you could also have one big figure that has many x and y axes. If you have 4 subplots, you get like 5 things, like the 4 axes and the entire figure. Now we have one subplot, there's one plot taking that one axis.
You can see it better when we have 2 subplots in one figure. Then you can see that we have 2 axes and again still one figure. It makes more sense when we have 2 subplots. For now, it's just the same thing, both of them. An axis in a figure. An axis, or the 2 axes in a figure. Adding title, again, will be useful everywhere. Let's copy and paste whatever we did here. Plotting the scatter and the plot and the line plot, and then put set a title. Set title, line and scatter. Scatter plot. This is my title, and I want to set my X label. Come on. This label to be, call it measurement X. Now I have a title and an X label. The line and the scatter plot can be easily separated into 2. Now we want to have 2 different subplots. Let's see how we do it. We want to have one figure, 2 axes, x1 and x2 as a tuple, plt.subplots. Let me put it on. 1 and 2. 1 and 2 means I want to have 1 row and 2 columns. You can have the reverse. So when I wanted to have only 1 subplot, I left it open. I left it empty. So when you leave it empty, it means 1 and 1. It means only 1 line, 1 row, 1 column. But when I want 1 row and 2 columns, I put 1 and 2. So what does it do for me? It creates 2 empty subplots. If I put 2 and 1, it will be columnar. Let's see. Okay. So for now, 1 and 2 is better. Then I want, can you see that this is really not nice, that they are so close to each other? This can be solved by fig.title tight layout. Now it's better. You can change the figure size, the whole figure size here. So you're saying I want 1 and 2. I want 1 rows and 2 columns of subplots, and my fig size to be 8 and 4. You will figure out how to play with these based on sorry, I didn't put equals, of course. So you see that it changed. And you will figure out what to put, why 4, 8, and 4. You will figure out based on your needs and your screen and your paper later. Okay, now I want to add things to this. Now I want to plot in one of my subplots, I want to plot my scatter plot. In the other one, I want to plot my line. So I say x1. Remember, we have two outputs for our subplots. We named it x1. I want x1 to plot a scatter for me. x1.scatter gets x and y, and its color to be red. My x2, I want to plot for me the x and y, and its line style to be dashed, like this, the same thing as we did before. Now, my x1 set title, I want to say this is my scatter plot. These are really simplistic, but it's good to focus on the functions than the data itself. So that's why I chose such a silly example. And my fig, I wanted to have tight layout. Okay, sorry, I had that before. Okay, perfect. I think everything is fine. So I plotted 2 things in the 2 axes, and I set the titles. Holy mistake, line style. I have another typo somewhere that I should figure.
Oh gosh.
Thank you. Thank you. Always use tab, not be like me. Okay, so here we have separate titles, separate plots. Okay, you know what? I'll show you. Change the color of, do the same thing. Now a challenge. Do the same thing. I'll show you this colors. Choose the name of the plot, this line. Change the color of this plot based on these colors. You can find them by Googling Google named colors in Matplotlib, and you will find the thousands of color names, and you can choose whatever you like. Where is it? Oh, you put it in the Etherpad?
In lecture notes, and so soon they did.
So go to this, find the name, find the color name. Maybe this is better. You can see it here. You should go from your own laptops. So next challenge. change the color of the plot based on whatever you want. For the sake of time, I suggest we go forward. So you can choose any color, just you have to define the color. Just say color, whatever name you want. We already did it. Instead of red, you just put another. We have a lot to cover, and we want to finish by 4. So how do you save whatever you did? It's again just easy. You have a fig. You have defined a fig. Whatever axis, 1 axis, 2 axis, how many subplots you have in that figure, you just need to now call the fig. So it's fig dot save fig, and give it a name. Scatter and line. .png. And we can also define the dot per inch to have better resolution. This will save your data. It doesn't show you anything, but you can see in your, if you go to files, you can see that it's being saved here. You can save the PDF. Again, the same thing, fig.save fig. So you won't need to, if you have different subplots, you don't need to be worried about all the subplots. It's just one fig, and you're calling the fig. Scatter and line .pdf. That's all. And for PDF, you don't need to define the DPI, and it will show up here, hopefully. Please show up here, PDF. Okay. Now, we really fast want to go. Can you put on the diamond data in the Etherpad, please? The thing. So we want to call a data. We want to find out how we deal with with large data sets. Probably we don't have just four dots. We have larger data sets. How to deal with oversaturated plotting caused by having a large data set. There's in Etherpad, please go and copy this. We want to read a CSV like before, like the Serbians, but here is from another link. I'll put it here, but it's probably hard for you to read it from here. If I show you the tail, so it's a data set of different measurements of thousands and thousands of diamonds. It has the carat, sorry if I'm not pronouncing it very well, the carat of the, the carat, the And the cut, the color, the clarity, the depth, something called table that I don't know what it is in diamond. I'm not a driller, so the price of it and XYZ. So this is your data set. And if you look at the info, you can see how big this data set is. So diamonds.info. If I use the tab, okay, we can see that we have around 54,000 data points. Everyone has this data point? Everyone is fine? Okay, let's try to plot it. Again, I know I should define fig and x and do the plot.subplots. And I want the scatter. I want to plot a scatter plot of my data with carrots, the caret of the diamonds and the price. And my data is diamonds. Let's see how the scatter plot looks like. You can see that it's pretty saturated. You don't get anything from this. You can do something. You can see that the dots are too big. Let's change the size. That is done by s equals 1 in the scatter. Okay, better. Another way is to change the alpha, the transparency. Again, better, but you can see that it's really oversaturated, close to 0. Before that, if we don't put labels, it's really not nice, even for yourself, to not put labels in your plots, because then after a while you're not remembering what you were plotting. So let's always add our plotting, labeling of our axis. SNS.set context. I want notebook. My font is 1.2. I want to set the title to be diamond prices, if you remember. My text label is caret. And my Y label is again.
There's a T after.
Notebook, font to scale, huh?
There's a T.
Context. Perfect. So now I know that I have the caret in the x-axis, the price in the y-axis, and these are the diamond prices. We see that this is very crowded here. Let's go and zoom in. How do we zoom in? By adding limits to our x-axis and y-axis. X.set xlim. I want it to be between 0.2 and 1.2. Sorry, I shouldn't have. And my y-lim be 204,000. I want it to go around 0. Still This time we're seeing a bit better what the data looks like. But yet another better way is to somehow plot this as a histogram. So we will have, if we want to say how many of these, for example, was in the bin between 0.2 to 0.5 and 500 and 1,000, how many of my data points were in this? We need a histogram, but a histogram in the third dimension. So we show the third dimension with color. You probably, again, familiar with this type of showing the histogram in heat maps. How we do that is by something, a function called hexbin. We will see how it looks like. You will see better if you didn't got what I mean. Let's do defining our subplots. And now I want my X to plot hexbin. This hexbin gets caret. I want it to get caret as X, price as Y, and data would be diamonds. So again, we will make it better, but here, each of these bins have a value that shows the number of your diamonds that had this price and this caret. This is not nice because it's showing all the bins, but we know that many of the bins had 0 counts. So let's tell it to just show me the bins that have a minimum of 1 count. Mean CNT to be 1. Okay, now we don't have a color in the, or you know, a color for our histogram where it's 0. So it's better. Definitely, again, as I said, we need our labeling. It's better to know, okay, I see that here it's really yellow and the rest are darker. We know based on what we know from heat maps and histograms that this probably means higher value, but what is the value? So you need to define the color bar. So I say, okay, color axis, I name it another thing, color axis, C-ax, to be fig dot color bar X plot. That's how you just need to know how you define it, which I didn't.
The color, the density.
Sorry?
What is the color mean?
Sorry, I didn't call it. Just a second. The color is the counts.
Is the density?
The count. The count. So in each bin, how many of your diamonds had this, for example, carat of 1 and price of 5,000? The bin, the intersection bin of 1 and 5,000, how many of your diamonds that had this carat and this price? Just the count. And now we see that, so this red thing means that more than 2,000 of my diamonds had this carat and this price. Let's just fast do the titling. That is very important. Big dot subtitle, meaning the superior title, the title that goes on top, is diamonds, diamond prices. X dot set X label. Let's copy paste this part. X label is carat and Y label is price. We know that. And now we want to also label our color bar. So we named it CAX. So now I'm calling, okay, CAX, set label as observation. Yeah, let's call it density. Count density, whatever you like. Okay. So this is better. Just to show you that we could, this is actually the same thing as histogram. Let's plot the histograms. Let's plot them as histograms. I want the histogram of the, here, for example, the diamond weight and diamond price. So I want two subplots. So I do fig and two axes, x1 and x2, the plt dot subplots 1 by 2, and fig size of n, fig size equals n and 4. Then my highest title, I want to be the figure title, sort of. I want to call it distribution plots. Now in XY, and in X1, I want histogram of carrots, the carrot, in 30 bins. Let's say 30 bins. And the data is diamonds. My title for the first one is diamond weight. And I want to set X label as being carat, of course. Then for X2, axis 2, I want a histogram of prices. Bins, again in 30 bins. And data is diamonds. My title is diamond price. And I know that it's in US dollar, my price. I do the de-spining here because when there are two, it's nicer when they don't have that overall thing, borders. I want it to be tight layout. Hopefully I don't have a typo, as always.
Things.
Yeah, at least.
Things equals to 30. S. B-I-N-S.
Bins.
Yes.
Perfect. These are our histograms that we were actually showing in colors in our previous. this operation is so common that in Seaborn, there's a built-in function that plots you the joint distribution, the thing that we did before, and the two histograms on the side, so that you have all the information. And it is called joint plot. Let's plot it. Is everyone fine? So we define subtitle, superior title as distribution plots. We just plotted two histograms of the same things that we were doing the joint distribution here. We're just plotting each of their histograms separately. It's the same thing. Let's do them all in one plot. Both this type of hex bin, so sort of hex bin, and the separate histograms. So we have SNS now. We have Seaborn, all of us. We want to call joint plot. We want our X to be the caret and Y to be the price. And data to be diamonds and kind to be hex. So it gives you the same hex bin that we plotted separately and the two histograms on the sides. Yeah, here. Joint plot. One line. Just so that, yes, please.
That p equals 0 is the p-value.
Yeah, here it shows the p-value as well. Yes, the Pearson correlation, it does everything for you. It's really too many things with one line. Just so that we have a better, yes, please. Yes, sure. So this was the joint plot. This was the histograms. And this was the hex bin. So we see that it's pretty much the same. You know what? Let's do. We can customize this to make it look exactly like what we had. I mean, better, more like the hex bin that we had here, to just have better visualization of to see that it's the same thing. Let's customize our joint plot in Seaborn. Oh, sorry. Up, more up.
Oh, that's good. That's good. So,
sorry, wait a bit.
That's probably the newest version. So there must be some other keyword must change.
yeah, so we're going to do the same keyword. It's telling me that students stop using it. Yeah, I love what I'm saying.
Okay. So I think now let's customize this type of joint plot to see that it's really the same as what you're plotting. But since this joint plot is both dealing with, both plotting you the histograms and the joint distribution, you have to give it whatever parameter you want to change. You should give it in or pass it in dictionaries for keywords for joint, keywords for marginals. These are called marginal histograms distributions, and this is the joint distribution. So you should give them separately. Let's see how it is done. So I call sns.jointplot. Let me put it up. Again, the same thing. First, I want to plot carat and price. And the data is diamonds. Because I'm doing all of them in row, I don't need to define data equals diamond because it's in its place, so it doesn't mix it. Kind is hex. Now, let's go down so that it's not getting. My joint keywords, KWS for keywords, joint keywords. I want it to be, for example, I want to get the color map to be, again, these are the things that, map. C map for a color map. I want the color map to be viridis. I know this because I know that viridis is that purple thing. So by time you Google these, you find all the color maps in that link, for example, all the color maps are there too, or just Google color maps, matplotlib, and you find all the names. So I want for the joint keywords, I want the C map to be viridis, and I want the minimum count to be 1. That's for my joint keywords. For my marginal keywords, KWS, I want to pass the color to be indigo, just to be the same as before. You can set anything just for today. Hopefully I don't have an iPhone. Yeah. This is pretty much like what we had. You can see that it's more visible, that they are the same thing. And you can see that the max in the marginal histograms are where the color bar has the highest color, the yellow. Yes, the code. Again, you can go to the documentation to see what else, what other parameters you can change and define. So I think about everyone okay? I want to point out that something about choosing the best or suitable color map. This Viridis, for example, is a nice color map. It's also important to find what color maps to use. It's wise to, let me show you. The jet rainbow color maps are usually not a very good idea to use because of different reasons. First, it's really advised that you use colors that are good, that are suitable for or accessible for colorblind people. That also makes it for people who have standard, I don't want to say normal, standard color vision to be also see your plots better. It's not just for them. And also that for plotting, for in printing, if you choose the colors that are good for colorblind people, it's usually also better in printing, better shown in printing. And also another point about or disadvantage of jet color scale is that, or the color map is that it has sharp transitions, and these sharp transitions may not be the same step size as your data points. So it will cause an illusion for the person who is viewing your data point or your plots that this is the way that data is also changing. Another disadvantage is that usually our eyes or our brain is tended to see yellow as more important or as highlight. So if you may not want exactly that part of your data to be highlighted and seen as an important feature of your data set. So it's usually better to use uniform, they call it uniform color maps that has a uniform step size, and they have a smooth transition between colors. Those are better. We have put this in our in the lesson content. We have linked to different resources that you can go and read more about this. But another good way to help visualization of your data and help people not make mistakes is to also add different markers, show different data points in different marker shapes. Let's see how to do that. Let's go back to our exercise and do that iris data. Let's plot the iris data and the 3 species with 3 different markers. So I want to do all SNS linear plot, linear model plot. I want to say my X to be sepal width, and my Y to be sepal length. My hue to be species. You know these things. We want the colors to be based on the species and the data to be iris. Then, because I don't need the regression line for now, I want to put the regression line as false. And now I put markers, I define markers. Markers to be the point, the square, and the diamond. Now, you have both different colors for your species and different marker shapes. It really helps visualizing your data. Again, if you want to have another color palette, that is better for colorblind people, for example, we have a palette named. So you can also define the palette. This is the same as color map for Matplotlib. In Seaborn, you call it palette. Color blind. This is the name of a palette that I know. Again, you can Google palettes in Seaborn and get all the names and see how they look and play with them. Sorry, palette has one L. And this is a better color palette. Or you may not like it, you may go to another color palette. Again, for different markers, I only gave you 3. You can Google for Matplotlib markers and see all the different notations or symbols for different markers. That's all. We have a challenge here that we can do or we can not do because it's I just want to tell you to let me show you. I just want to tell you to go to this website, which is this website, Colorblindness Simulator. I want you to choose any color you want and then go to upload your figure to this website and see how it looks like for a colorblind person, how it looks to them. But since it was a very long day and it's 10 minutes to 4, I think it's better to ask any questions if you have, or any points that was vague. All of these 2 days, all the things that we said in 2 days, they are up on the website. This is the last part. If you like, Google for different markers and plot the same thing with different markers or different palettes and upload your figure. Otherwise, it's open to any questions or any point of discussions.
How do we save this figure?
So we had it once. We had to choose. Where's my marker? I can't find my not here. So we had to remember we had to define our figure. So I defined a figure here on top. Big. Okay. And because it was only one axis, big and X is do it with this and this?
Yes,
Yes, sorry. Take away this? Then how can I save it then?
So it actually, Ellen plus grace is or
So then I say the just, wait.
so that it has access. It's not like you get access.
Yeah.
Ax.save.
Ax.savefig. My, let's call it.
That's not the access that variable name. It's actually returning.
My iris.png. Something like that. And my iris should be here. It will appear. It takes time. Here. So I didn't even need to define a fig. Should I wait for more questions?
You can end and then people can ask questions as they go.
So what is the difference between working on Jupyter Lab and Jupyter Notebook when we open our Anaconda Navigator? Like what would you recommend?
Well, there is no. It's just a newer version of Jupyter. Jupyter Lab is just a newer version of Jupyter Notebook, and has more features. Has a nicer set of settings of the tools. It's different. It sets these, for example, commands and cell tools here. And it was not the same like this in Jupyter Notebook. It was more plain. Here you have more accessibility to all your tools and stuff. But I use Jupyter Lab. I used Jupyter Lab from the first months that it was created. So I haven't used Jupyter Notebook that much. So I don't know. I don't know exactly what are the details of the differences, but there is no difference. You can run anything that we wrote here. All of them are runnable, executable in the Jupyter Notebook as well. If there's no question, we can call it adjourned. Yes, end. Thank you for attending the 2 days. I hope you've learned and be motivated to use these languages more often in your work. And don't worry, you don't need to memorize all of these. First, you have them at your hand when you go home, and then by time you will remember some things, and it's always Google and find things, answers to things. So, yeah, that's it.
Thank you.
Okay, I have just a few final announcements. So the first one is to do the follow-up survey, which is linked on the website. That's mostly for the software data carpentry organization. So that's for them. And then we really appreciate feedback from the sticky notes. So again, can you leave feedback on your pink and yellow stickies for Sarah's session? But then I gave you all a blue sticky. If you could write something about the whole workshop, either good or improvement on there, we would really appreciate that. I also want to mention again, could you put up the UT Coders website? I also want to mention UT Coders again. So UT Coders is the group that organizes these. We meet every Thursday here at 6 p.m. in the Mad Lab. And if you go to events, we have a couple of, so our next event on this Thursday is Intro to LaTeX. And then in July, you can see we have a bunch more Python events. So if you like this, if you want to learn more Python, want to kind of casually practice what you've learned, come to those. We also do a co-working session on Tuesday mornings every 2 weeks. And one other thing, we're going to have another workshop that's basically going to be exactly the same as this in July 12 and 13. So if you know people that wanted to come but couldn't, tell them about that one. It's going to be pretty much exactly the same. Finally, if you're interested in being an instructor for this type of thing or learning more about it or anything like that, it's not as scary as it might sound. You don't have to be an expert. We're happy to talk about that. It's a super smooth process to become an instructor. I think that's it. Thanks so much for coming, everyone.
I'd really be grateful if you put the comments for the after